Hey, it's Dr. Inductor again, and I have another video about resistance. Okay, it's gonna just talk a little bit more about it, and oh yeah, let's just get started. No reason I should blabber. Okay, let's start with the definition of an ohm. Okay, an ohm is a resistance that limits a conductor's current to 1 amp when 1 volt is applied. And this makes perfect sense if we recall Ohm's law, where resistance equals voltage divided by current, okay? So, if voltage is 1, okay, and current is 1 amp, so that's 1 divided by 1, which is 1, okay? That makes perfect sense. Now, there are a couple factors that influence resistance, okay? And I'm going to talk about them right now. The first one I want you to know about is diameter, okay? And that's just like the gauge of the wire, alright? Just imagine it like a pipe. As the diameter rises, as if the wire gets thicker, then the resistance gets lower, okay? Because it's easier for the electrons to flow when there's a bigger pipe. There's less opposition to the flow, okay? The next one is length, or wire feet, we call it's not always measured in feet, but yeah, wire feet is just a unit that we give length of a wire, okay? And this is the same, or this is a different principle. As the length gets lower, the resistance gets lower, and if the length gets higher, the resistance gets higher, okay? Because it's harder for electrons to flow farther. It's harder for them to go farther because it takes more energy, okay? And therefore there's more resistance. Just think about like a water pipe. I mean, if you have a longer pipe, it takes longer time for the water to flow through the whole thing, right? Same thing with electrons, okay? The next one is temperature, and this one's a little non-intuitive, but when you have your wire, you have all of these particles in the wire that make it up. If it's a conductor, a metal conductor, or just a wire, it'll have metal atoms, and these things are bouncing around, okay? And the hotter it gets, the higher the temperature, the more these things will bounce around. And these poor little electrons that are trying to flow through will get blocked because these atoms are getting in their way, the ones that are bouncing around. So that the higher the temperature, the higher the resistance. Or the lower the temperature, the lower resistance. And actually, if we have a super low temperature, like if we douse some metal in if we douse metal in something like liquid nitrogen, we create something called a superconductor, which has almost zero resistance, okay? Next one is, quite frankly, the obvious one. It's material. And if you follow my arrow down to here, I'll start explaining some of the materials. We have conductors, okay? Conductors have low resistance, and they're things like metal and water, okay, and salt water, alright, just things like that. The next kind of materials are resistors, and they have high resistance, but they still let current flow, and that's things like carbon, and actually flesh, gross, but yeah, alright. And then an insulator, it doesn't let current flow, so like air, we'd say it has infinite resistance. Air, actually a vacuum also, I don't mean vacuums, I mean a vacuum, like the lack of air pressure or any material, okay? And paper, and you know, things like that, wood, glass, right? Okay, the last one is a semiconductor, okay? That's things like silicon, cesium oxide, you know, or maybe you don't know, but so yeah, semiconductors, they only conduct given a certain criteria. Like p-type silicon will only conduct when it's given a positive charge, and n-type silicon will only conduct when it's given a negative charge. And cesium oxide will actually produce a charge when exposed to light, and that's what gives us solar panels, and I'll do a whole video on that in the future, okay? But for now, you know a little bit more about resistance. I can get into resistors later, okay? But you're good for right now. Let's move on.